All right, let's dive into one of the most powerful and maybe one of the most elegant ideas humans have ever come up with, the equation.
So, let me ask you something to get us started. Think about a planet spinning through space in its orbit. Then, think about the way heat from a fireplace slowly fills a room. And now, picture a perfect circle. On the surface, they seem totally unrelated, right? What could possibly connect them?
Well, the answer is the equation. Yep, that one simple concept is the language we use to describe all of these incredible patterns in the universe. It's absolutely fundamental. And today, we're going to break down what an equation really is.
So to really understand the power of equations, we've got to start with the single most important idea behind them, this idea of a perfect balance.
So, what is an equation, really? Well, the official definition is pretty straightforward. It's just the statement that two things are equal. You've got some stuff on the left, some stuff on the right, and that little symbol in the middle, the equal sign, that's the real star of the show. It's making a promise. What's on one side is the same as what's on the other. The best way to think about this, honestly, is to picture one of those old-school balancing scales. You know the kind. If that scale is perfectly level, it means the weight on the left is exactly the same as the weight on the right. An equation is just the mathematical version of that. Perfect balance. And you know, for thousands of years, people didn't even have a symbol for this. They just wrote out the words, is equal to. Can you imagine? It wasn't until 1557 that a Welsh mathematician named Robert Recorde decided he was tired of writing it over and over again. So, in his book, he just drew two parallel lines.
And his reason for it? It's actually kind of beautiful. He chose two parallel lines because, as he put it, no two things can be more equal. Just a simple, elegant idea for one of the most important symbols we have.
But an equation isn't just something to look at, right? The whole point is to use it. And to do that, we need to know the rules of the game, the rules for keeping that scale perfectly balanced.
And the golden rule is super simple. Whatever you do to one side of the equation, you have to do the exact same thing to the other. You want to add 5 to the left? Fine, but you have to add 5 to the right. Want to divide the right side by 2? You have to divide the left side by 2 too. That's it. That's the core rule.
These rules are basically the entire foundation of algebra. When you follow them, you can change how an equation looks without ever changing the truth it represents. You're just shifting the weights around, but that scale, it stays perfectly balanced. So why do we even want to rearrange these things? Well, most of the time, it's to find a hidden piece of information. You know, that mysterious letter X that we all remember from school? It's all about solving for the unknown. So equations usually have two kinds of pieces. First, you have your unknowns. Those are the variables we're actually trying to find, like X, Y, or Z. And then you have the parameters. Those are the known values, the constants we're already given, which we often write as A, B, or C. See, an equation with a variable isn't just a statement that's always true. It's more like a condition. It's a puzzle. The equation is only true for a very specific value of that unknown, and our job is to find out what that value is.
And how do we solve that puzzle? We use those rules of equality we just talked about. We add, subtract, multiply, and divide our way through it, carefully rearranging everything until the unknown variable is sitting all by itself on one side of the equal sign. That's it. That's the game.
Okay, but this is where it gets really cool, because equations can do so much more than just find a single number. This is where that simple idea of balance just explodes to describe the entire world around us.
So we know equations can solve for a value. Fine, but can they do more? Can a string of symbols, just an equation, actually describe a physical shape? Oh, you bet it can. Take a look at this famous little equation. It might look simple, but it describes every single point on a perfect circle. It's not finding just one answer. It's defining an infinite collection of points that all work together to create a shape we all recognize. It's pretty amazing.
And what if you have a bunch of unknowns at once? Well, that's where you use a system of equations. You take all three of these equations and you consider them together as a single puzzle. When you do that, you can find the one unique solution for x, y times z that makes all three statements true at the very same time. This is used everywhere, from economics to engineering.
But let's be real. The world isn't static. Things are always moving, growing, changing. And to describe that kind of dynamic action, we need a more powerful kind of equation, one that deals with rates of change. We call these differential equations.
And what can they describe? Well, pretty much everything.
Seriously, the vibrations that create sound, the flow of heat, the way water moves, the laws of electricity, even the mind-bending rules of quantum mechanics. They are the language of physics.
And this is what's so wild. You'd think some things, like chaos, would be impossible to describe with an equation, but they're not. In fact, the solution to certain differential equations can reveal these unbelievably beautiful and intricate patterns called strange attractors, hiding right inside a system that looks completely random. It's finding order in the chaos.
Which brings us to the big picture here. When you step back and look at all of this, you start to realize that an equation is so much more than a problem in a math textbook.
It all comes down to this. An equation is a language. It's a perfectly precise and universal way of describing the relationships and patterns that make up our universe. The same equation for gravity that works here on Earth, it works on the other side of the galaxy too. It's a fundamental truth.
From a simple balancing scale all the way to the hidden order inside of chaos, equations are our single most powerful tool for making sense of it all, which really just leaves us with one final, fascinating question. The universe is full of patterns we don't understand yet. So what's the next one we'll finally be able to describe with an equation?